Okay, welcome to Math 20, and in this video we're going to talk about ratios. So a ratio is like a fraction. It's a comparison of two numbers, usually using division. So that's why it looks exactly like a fraction, because we've talked about how the divide sign is a little tiny fraction. So let's see how we use this. A couple of different ways to write ratios. If I'm just comparing, okay, the ratio 3 to 5, I'm comparing 3 to 5. Then I can write it as 3 to 5, 3 colon 5, or the fraction way, 3 over 5. I just wrote the 5 accidentally first. But that order does matter. If I'm comparing 5 to 3, 5 to 3, then I would put the 5 first or the 5 on top, because that's my comparison. So let's just think about this in terms of some context. If I want to compare the width to the length, length of a rectangle, and here's my rectangle, a beautiful drawing of a rectangle, okay, is 7 centimeters to 19 centimeters. So when we say that the width, and then I say 7 centimeters first, then that's the number that corresponds to the width. So 7 centimeters to 19 centimeters. Now, one thing to notice is that the centimeters actually, because centimeters divided by centimeters, they would cancel. So we could say the width to the length is 7 to 19. And some of these examples are coming from your book too, so you can actually look through the textbook at these. Okay, let's do another example. What if I said the ratio of men to women in class is 2 to 3. That would mean that the men, there was 2 men for every 3 women. This is the men, this is the women, because of the order. Now, just given that bit of information, you might be asked to write, what's the ratio of men to total? And again, if we're thinking about this one little classroom, if I have 2 men for every 3 women, then I have a total of 5 people in the class. So the ratio of men to total would be 2 to 5. If I wanted the ratio of women to men, then I would want to flip that order, because I know, since I said the ratio of men to women was 2 to 3, that order is maintained. So if I switch the order, then I have to switch the numbers, is 3 to 2. And again, I could say maybe I want the ratio of total to women would be 5 total to 3 women, or 5 over 3. And for these examples for ratios, we're not going to want to change them to improper fractions, because that would just look kind of weird. I wouldn't really be able to maintain who is who. Okay? And it doesn't necessarily also mean that there's only 2 men in the class and there's only 3 women. This is actually a reduced ratio. So let's talk about reducing for a minute. Let's say in the actual classroom, so I'm going to draw the classroom, okay, that there's actually 15 men and 30 women. Okay, this is a different example. I'm just making this up. So the ratio of men to women is 15 to 30. Okay, so if I write that ratio of men to women, then I would have 15 over 30. And some of you might notice, well, that fraction reduces. So you can always reduce a fraction the same way. So let's just reduce. And you might notice that 15 is half of 30, so 15 goes into both of these. 15 goes in here once, 15 goes in here 2 times. So the ratio is actually 1 to 2, and that's how you usually typically hear the ratio expressed. The ratio of men to women is 1 to 2, men to women, and then conversely, the ratio of women to men is 2 to 1, or 2 over 1, which is really 2. The same thing as 2. But because we're comparing them, even though it's awkward to see the 1 in the denominator, we would really want to say that, because otherwise a lot of times people see the number 2 and they're like, well, what's the other number? So might as well just keep it over 1. Okay, so there's twice as many women in this class as there are men. Let me see here. So this is pretty much what I wanted to talk about in terms of ratios, is always the idea of simplifying. Okay, let's look actually at a more complicated one. This one is from the book, and it's using an improper fraction. So this says Lauren sank a 22.5-foot putt and Carrie sank a 30-foot putt. Express the ratio of the two distances. So we have 22.5 compared to 30, and they're both in terms of feet. And that's important because, if one was inches and the other was feet, then there would be two different units. So if I'm going to compare these in a ratio, 22.5 feet over 30 feet, well, the units are the same. So immediately I could reduce and cancel out the units, and then I'm just comparing the exact same units, 22.5 to 30. But isn't that a little awkward to see that fraction within a fraction? So because this is a division problem, this is the same thing as 22.5 divided by 30. Well, to divide fractions, if we have an improper fraction, we always want to make it into a mixed number. And then when we divide fractions, we multiply by the reciprocal. So I'm going to change this into a mixed number. And to do that, remember we go 2 times 22 is 44, plus 1 is 45 over 2, times the reciprocal of 30 is 1 over 30. So we're going to, when we divide fractions, we multiply by the reciprocal, and that's really just the reciprocal. Okay, it's a funny way of remembering that. And then again, we can always, when we're multiplying fractions, we can always cross cancel, and so we're going to cross cancel this. I happen to know that 15 goes into both of these, and I use the 15s. You can really think about it in terms of time. 15 minutes being a quarter of an hour, 30 minutes being a half an hour, 45 minutes being 3/4 of an hour. So 15 goes in here twice, 15 goes in here 3 times, and then we would multiply across 3 over 4. Okay, so the ratio of their two distances would be 3 to 4. And we would go ahead and leave it like that. Let's look at an example they have in the book also with decimals. Okay, it really looks funny to see decimals on top of fractions as well. So they're saying here the diameter to a 20-ounce bottle is 2.8 inches to the diameter of a 2-liter bottle is 5.25 inches, and they're asking us to express the ratio of the two diameters. So when we're comparing these, we would have 2.8 over 5.25. Well, the problem here again is that we don't really like to see decimals mixed up in our fractions. It's not a very convenient comparison. So if I multiply the numerator and the denominator by the same thing, I'm really multiplying by one whole, which we know whenever we multiply by 1, we don't change the value. So if I multiply by 100 over 100, and why am I doing that? So that I can move the decimal to make this a whole number. So this becomes 280 over 525. And you might be asking, well, how is that easy to reduce now? We want to look for, once they're whole numbers, it's much easier to find a number that's going to go into both numbers. I can see, since this ends in a 0 and this ends in a 5, that I could reduce them by 5. And the book actually shows me that I can reduce by 35. Well, I could have started whittling it away. So if I divide them both by 5, then we might see that they're both divisible by 7. So the reduced fraction that the book gets is 8 over 15. Maybe I'll show an easier example of that. So let's just do another decimal example. So 2.5 over 0.25. Okay, and again, I'm going to want to multiply by a number that will get rid of my decimal. So if I want to move this decimal over 2 places, this one I only want to move over 1, but I have to multiply by the same thing. So I'm going to multiply by 100 over 100. That moves the decimal here 2 places and this 2 places. So I get 250 over 25. Yeah, that is a much easier example to see. Do you see that the only difference here is that I'm missing a 0 here? So this reduces to 10 over 1. Oops, 10 over 1. Because 25 goes into 25 one time, and then you have that 0 placeholder. So 25 actually goes into 250 10 times. But again, when we leave it as a ratio, let's leave it as a fraction so that we can see what other number we're comparing it to. Okay, and then here's another example where we have to change the units. So let's say that I'm comparing 2 hours to 75 minutes. Well, right away, 75 minutes is actually not as long as 2 hours, but the 2 is a smaller number than 75. So this is the reason why if I compare 2 hours to 75 minutes, you see I cannot just cancel out those units because they're not the same units. So we could either change the 75 minutes into hours, or we could change the hours into minutes. So how many minutes are there in 1 hour? 60 minutes. How many minutes are there in 2 hours? That would be 120 minutes. 120 minutes to 75 minutes, and then we could go ahead and reduce it from there. So what number goes evenly into both of these? Again, when we get back to the idea of a clock, we can use multiples of 15 very easily. 15 minutes, 15 minutes, 15 minutes. So if I go around the clock 1 time, that's how I get 60 minutes. To get 75, I need 60 plus 15. So I'm dividing them both by 15. Okay? Because our clock is easily divided into 15-minute segments. That's why we say a quarter of an hour is 15 minutes. So they're both divisible by 15, which remember is the same thing as multiplying by one whole, or dividing, sorry, by one whole. Anything divided by one whole remains the same value. 15, so 1 hour is 60, 1 hour in 15 minutes, so that's 1, 2, 3, 4, 5. 15 goes into 75 5 times, and then if I go around twice, 2 hours, that's 4 times around. 1, 2, 3, 4, 5, 6, 7, 8 times total. So 4 segments of 15 would be 1 hour. And for 2 hours, I go around 4 and then 4 more. That's 8 times. So 15 goes into 120 8 times, or use your calculator. Now we're going to leave that as an improper fraction because we want to keep that comparison. Since there was an original word problem that went with this. It says Joe took 2 hours to complete his final. Jamie took 75 minutes. Write the ratio of the 2 times in simplest forms. So we could say, Jamie took 8, or Joe took 8 and Jamie took 5, as if we're comparing that reduced fraction. Okay, so hopefully that helps a little bit with ratios, and you'll want to go ahead and do some of these homework problems from your book or from Connect Math.